Hello there, and welcome to the second part in this C4, the periodic table flipped learning video. I'll go through the objectives in a moment, but this video will be all about electron configuration and electron structure. Enjoy. Okay, so we are carrying on with atomic structure in this lesson, and by the end of this lesson, this video, you should understand these three objectives. Okay, so we're going to look at how electrons are arranged in atoms. You should be able to deduce the electron configuration of the first 20 elements, and we should know how the electron configuration relates to the position of the element in the periodic table. Okay, so if you remember back to last lesson, we looked at Niels Bohr's model of the atom, and we had this structure here. Now we've got the nucleus with the protons and the neutrons. What we're looking at now is the electrons. Okay, now you can see in this one that we've got what we call orbitals going around the nucleus. Now the orbitals can also be described as energy levels or electron shells. Now with the electron shells, you can have a certain number of electrons in them. Now you can see in here we've got 1, 2 electrons. Now in that first shell, so the shell closest to the nucleus, you can only have 2 electrons. Now in this second shell, we can see that there's 2 electrons in there, but the maximum you can have in the second shell is up to 8. In the third shell you can have up to 8 as well. Okay, and later on in the video we'll look at how the periodic table structure looks at how many shells we've got and the number of electrons in there. Now the other thing to remember as well is when we looked at the atomic number, it relates to the number of protons. Okay, now the number of protons you can see here is 1, 2, 3, 4. Now the number of protons will be the same as the number of electrons. So we've got 1, 2, 3, 4. So the information we can get on the periodic table for sodium looks like this, where we've got the 23, which is the atomic mass, and then we've got the 11 at the bottom, which is the atomic number. Now we know that the atomic number is equal to the number of protons. Now protons are positive and electrons are negative, so in a neutral atom the protons will equal the number of electrons. So for sodium we've got 11 protons, so therefore we've got 11 neutrons. Now if we put in our nucleus for sodium, now in that nucleus we've got 11 protons. Now we can put in our 11 electrons into our sodium atom. Now if you remember from the previous slide, we have two electrons that can go on that first shell. So what we can do is we can put our electrons on that first shell. Okay, so let's just move that electron. Okay, so we've got 1 electron and then 2 electrons. Okay, now on the second shell we can have up to 8. So we've got 1, 2, 3, 4. It's not in a very good place there. 5, 6, 7, 8. Right, I've got a couple that don't look quite right in there, so let's move those. Okay, so we've got now 1, 2 and then 8, so we've got 10 electrons in total. Okay, so if we put our third shell Okay, so we've got 10 electrons, we've got 1 left, so we've got the 1 electron that goes on that outer shell. Okay. Now we'll have a look at another example. So we're going to have a look at oxygen. Now, if we put our nucleus in, okay, now in the nucleus there'll be 8 protons, so we need to put in 8 electrons. So if we put our first shell, okay, so we can put in 1, 2 electrons in that first shell. Okay, now in the next shell we've got 6 electrons left, so we've put 1, 2, 3, 4, 5, 6. Now we can record the electronic configuration for oxygen by showing the numbers. So we can show that in the first shell we have 2 electrons, and then in the second shell we have 6. So we can show the electronic configuration as 2, 6. Okay, now what we're going to look at now is the electron configuration and the patterns that we get with the periodic table. So if we have a look at the periodic table, we can see that it's arranged in groups going down and periods going across. Now we've got 8 groups. We've got group 1, group 2, group 3, group 4, group 5, group 6, group 7, and then this one can be known, or is known as group 8 or group 0. Now these in the middle, the transition metals and the lanthanide and actinide series, have a slightly different rule, but we'll come to those later on. Now we need to know the electron configuration all the way up to all of these, up to calcium here. Now it follows a very, very simple pattern that in group 1 they have 1 electron in their outer shell. Group 2 has 2 electrons, group 3 have 3 electrons, group 4, 4, and so on. Now group 8 or group 0 is slightly different. Group 8 or group 0 has a completely full outer shell. So for example, helium here has 2 electrons in that first shell. Neon has 8 electrons in its outer shell. Now the periods that go across, that tells you how many shells there are. So in the first period there is only 1 shell, so hydrogen and helium only have 1 shell. Period 2 have 2 shells, and period 3 have 3 shells. So this makes it easy to identify what element an atom belongs to. So if we take this example that we've seen a couple of times now, we've got the nucleus here, and then in this first shell we've got 2 electrons, and second shell we've got 2 electrons. So we've got 2 shells with 2 electrons in that outer shell. So if we go back to the periodic table, if we have a look for, it's going to be in group 2 because there are 2 electrons in that outer shell. It's in period 2, so it will be beryllium. So beryllium is that atom. So you can identify whichever atom you want, or be able to work out what the electronic configuration is by looking at their configure or their position in the periodic table. So if we take another example, so we'll write down the electron configuration, and it is 2, 8, 4. Okay, so 2, 8, 4 is the electron configuration. So it's got 1, 2, 3 shells. So we go 1, 2, 3. So it's going to be in this period, and it's got 1, 2, 3 3, 4 electrons. So the atom that it is silicon. Okay, now you need to be able to do this for all of them up to calcium. Okay, so what we've looked at then is we've looked at the electron configuration. We've looked at where the electrons go. We fill in from the inner shell where there is a maximum of 2 electrons, then the second shell 8, and then the third shell 8, and so on. Okay, so we've looked at a couple of examples. We've looked at oxygen and sodium, and then we've also looked at the how the periodic table fits in with the electron structure. So the period that it's in relates to the number of shells, and then the group that it's in relates to the number of electrons in that outer shell. Anyway, I hope you got a lot from this. Bye.